Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 27, 2026, just about 3 days ago. It introduces a training paradigm that effectively closes the fidelity horizon gap in video synthesis, allowing models to generate minute-long videos that are both narratively consistent and visually sharp. The paper is titled, Mode Seeking Meets Mean Seeking for Fast Long Video Generation. And as we'll see later, the method achieves remarkable improvements in subject consistency and image quality compared to standard baselines. Figure 1 illustrates why scaling videos is fundamentally different from scaling images. The top panel shows that increasing image resolution is largely an interpolation task, where the model simply fills in details within a fixed spatial frame. By contrast, the bottom panel demonstrates that extending video duration requires temporal extrapolation. Here, the model cannot just densify existing data. Instead, it must invent entirely new events and maintain causal structure far into the future, which explains why traditional upscaling methods fail when applied to time. Figure 2 outlines the decoupled diffusion transformer architecture. On the left, a shared encoder processes video data into a unified representation, shown as the green bar. The system then splits into two heads. The top path is the flow matching head, which uses a mean-seeking objective on real long videos to capture global narrative structure. In contrast, the bottom path is the distribution matching head. It employs a mode-seeking approach, aligning sliding windows with a frozen expert teacher to ensure local details remain sharp. So Table 1 presents the quantitative results, comparing the new method against several baselines on metrics like consistency and quality. A key advantage here is efficiency, shown in the NFE column, which stands for number of function evaluations. While standard supervised fine-tuning takes 50 steps, the proposed method in the bottom row requires only 4. Despite this speed, it achieves the highest scores for dynamic degree and image quality. Although baselines like COSVID show slightly higher subject consistency, the authors note those models often produce static or oversaturated videos to game the metric, whereas this approach maintains genuine motion. Well, moving from the numbers to the actual visuals, Figure 3 displays qualitative results across diverse scenarios. The columns track the video progression, marking timestamps from 5 seconds on the left up to 30 seconds on the right. Notice how the red sports car in the second row maintains its geometry and motion seamlessly. Similarly, the snowboarder in the bottom row stays distinct against the background, showing that the method preserves sharp local details while keeping the global narrative intact. Now, Figure 4 provides a direct qualitative comparison against the baseline methods. The top rows display results from long context supervised fine-tuning and mixed length supervised fine-tuning. While these approaches keep the story together, they suffer from significant blurriness, failing to maintain crisp textures. In the middle rows, teacher-only methods like COSVID and self-forcing show severe quality degradation as the video progresses. Finally, the bottom row demonstrates the proposed method, which stands out by keeping the visuals sharp and the motion consistent across the full 30-second horizon. Alright, having seen the visual proof, Table 2 now quantifies exactly which parts of the system drive those gains through an ablation study. An ablation study involves removing specific components to measure their individual impact. The top row reveals that stripping away the dual-head architecture entirely causes the sharpest drop, with quality plummeting to roughly 0.53. The middle rows show that removing either the sliding window distillation or the supervised fine-tuning also degrades performance. Consequently, the bottom row confirms that the full model combines these elements to achieve the highest scores across consistency and quality. So wrapping up, this paper shows that we do not need massive datasets of perfect, long videos to solve the coherence problem. By decoupling global narrative structure from local texture fidelity, the authors successfully bridge the gap between short-term sharpness and long-term consistency. It represents a promising step toward efficient, high-quality video synthesis. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.